With the growth in size and use of the nation's highways and the need to maintain them, drivers encounter construction and maintenance zones more frequently. But drivers do not see them as improving the system. They only see these operations as impediments. In a work zone, drivers are faced with changing and unexpected traffic conditions. So traffic control device application should conform to or be of higher standards than normal manual and uniform traffic control devices, warning and regulatory standards. In this program, we will cover the basic principles of work zone safety, traffic control zones, planning for traffic control, the function of traffic control devices, and typical applications. Let's take a look at some basic principles. First, traffic safety in work zones requires planning for construction activity and designing a work zone device layout. When performing these steps, maintain emphasis on workers, drivers, and pedestrians. The same safety principles which govern design of permanent roadway and roadside areas also govern construction and maintenance sites. That means a traffic control plan is required. The plan is a blueprint for handling traffic through the work zone. It should include traffic control strategies, staffing requirements, use of specific devices, and design of geometric features such as tapers. A second principle is that traffic movement should be inhibited as little as practical. The best way to do this is to schedule and stage work operations in a way that minimizes driver exposure to unexpected situations. Also, avoid abrupt changes in roadway geometrics, such as dropped lanes or roadway transitions, that force drivers to make rapid maneuvers. Don't forget to provide for safe operation and storage of work vehicles. And remember, drivers will reduce their speeds only when they think they have seen a real need to do so, which relates to the third principle. Provide clear and positive guidance for drivers in the approach area and as they go through the construction and maintenance work area. To do this, first install temporary devices to maintain guidance while permanent signs are missing. This will protect workers during the operation. Then, remove any existing devices that will be inappropriate once there is a work zone, because they might confuse or contradict work zone devices. Next, install pavement markings, signing, and channelization devices such as traffic cones or barricades. Remember, they must be effective during nighttime and bad weather. If special conditions mean none of these devices will be effective, then use flaggers. A final principle calls for routine inspections. Drive-through inspections can check for safe travel paths and visibility under all conditions. Inspectors are a key element. They must be properly trained in work zone traffic control device application, and they must have the authority to modify traffic control when necessary. As part of their inspections, they must consider varying traffic conditions such as traffic volume and weather. And they must periodically review accident data to help them constantly improve safety conditions. Maintenance problems discovered by an inspector should be remedied as soon as possible. Let's look briefly at a typical traffic control zone. Most traffic control zones can be divided into 5 parts: the advance warning area, the transition area, buffer space, the work area, and the termination area. The advance warning area tells traffic what to expect ahead. Drivers must have enough time to react and alter their driving patterns. Depending on the kind of work zone, the advance warning area may have a few or a large number of devices. For most operations on freeways, the advance warning area should be 1 kilometer or more. For low to moderate volume, primary and secondary highways, it should be 500 meters. And for local, urban streets, 1 block will usually be adequate. The transition area moves traffic out of its normal path. This is especially necessary if work is being done in the traveled lane. The transition area channels drivers clearly to a new path. A taper is a series of channelizing devices and pavement markings placed at progressive offsets from the lane's edge to move traffic out of its normal path. There are lane closure tapers, two-way traffic tapers, shoulder closure tapers, and downstream tapers. The taper length is a function of the speed limit and the width of the traveled lane. For a moving operation, a shadow vehicle is appropriate. Buffer space is the open or unoccupied space between the transition area and the work area. It protects both traffic and workers. If a driver misses the advance warning and the transition area, it gives room to stop. The buffer space must be free of equipment, workers, and materials. Channeling devices should be continued in this area. If the operation is a moving one, this area is the space between the shadow vehicle and the work vehicle. The work area is the portion of a roadway where work activity is going on. It is closed to traffic and is the area set aside for workers, equipment, and materials. There are several ways to set up the work area. They include channelizing devices between the work area and the traveled way, and flags and flashing lights on work vehicles exposed to traffic. If a work area must remain overnight, it should be set up with more visible delineation. The termination area provides a short distance for traffic to clear the work area and return to the normal traffic lanes. This area begins at the downstream end of the work area and goes until there is an end construction or end roadwork sign. Normally, the termination area has a reverse taper guiding traffic back to its normal path. Planning for traffic control has one ultimate goal: maximize safety and convenience at a reasonable cost, and consider the hazards and problems involved. This means minimizing accidents while maximizing convenience. There are several basic ways to minimize accidents, such as using traffic control devices which are visible and effective, as well as warning drivers well in advance of work zones. Avoiding introducing severely restricted travel paths in the approach to the work areas or within the work area. Using lightweight, less hazardous channelizing devices and crash cushions on barrier ends. Planning so there are no conflicts with traffic and workers and equipment. Consider using portable barriers. Providing night visibility with floodlights, retro-reflectorized devices, warning lights, and pavement markings. Providing pedestrian walkways between traffic and work activities. Storing equipment and materials outside the buffer area, the area which an errant vehicle may need to return safely to the traveled lane. Providing workers safe access to work and storage sites within the work area. Designing detours and crossovers for a speed no less than 15 kilometers per hour below the speed limit of the approach roadway. A difference in elevation between two lanes or a lane and the shoulder is called pavement drop-off. This situation requires some special attention. There are several precautions to take. Avoid drop-offs greater than 5 centimeters left overnight and immediately adjacent to traffic. They have a high accident potential. Specify that the contractor schedule resurfacing or construction operations so that no drop-off is unprotected overnight. Place a wedge of material along the face of the drop-off. The wedge should consist of a stable material placed at a slope of 3:1 or flatter. Put drop-off warning signs in advance and throughout the drop-off treatment. Place channelizing devices along the traffic side of the hazard 1 meter from the travel lane. The spacing of the devices in meters parallel to traffic should be about 1/3 the speed limit in kilometers per hour. In other words, if the speed limit is 60 kilometers per hour, place the devices 20 meters apart. In transition areas, the spacing should be 1/6 the speed limit. There are also several basic ways to maximize convenience, such as advising the public of major anticipated traffic delays prior to start of work. Changeable message signs work very well for this purpose. Avoiding scheduling work during peak hours and holidays. Closing only lanes that must be closed and reopening them as soon as is practical. Avoiding severe speed reductions. Preparing an alternate route plan in case of an accident or other emergency. Balancing safety with public convenience is a large part of the traffic control plan. Let's look generally at the plan. A traffic control plan is a blueprint for handling traffic through the work zone. It is required for all federal aid projects. It should include traffic control strategies, staffing requirements, use of specific devices, and design of geometric features such as tapers. When it is complete, it should be sent to everyone involved with or affected by the work zone operation, such as contractors and utility companies. Others that should be contacted include police, schools, businesses, and homeowners, local government officials, and towing services. Traffic control devices work together to provide a safe travel path through a work zone site. Devices include signs, signals, pavement markings, and delineators, which are covered in the videotapes Worldwide Traffic Sign Systems and Markings and Islands. More specific to work zones are channelizing devices, lighting devices, shadow vehicles, and flagging procedures. There are three kinds of signs: regulatory signs that impose legal restrictions, warning signs that give notice of conditions that are potentially hazardous to traffic, and guide or informational signs that show destinations, directions, distances, services, points of interest, and other geographic or cultural information. Markings outline the vehicular path leading traffic safely around a work area. There are pavement markings used by drivers as a primary means of guidance, and delineators or lights used to supplement other devices by further defining a safe path. Devices specific to work zones include channelizing devices that warn traffic away from or around a work area. There are drums, tubular markers, and cones. Lighting devices illuminate a driver's safe path around a work area under nighttime conditions. Again, there are several types, such as warning lights, flashing vehicle lights, flashing arrow panels, and hazard identification beacons. Shadow vehicles follow behind moving work zone operations to assist in traffic control. Signs and other devices are often used on shadow vehicles. They may also have portable crash cushions attached to the rear bumper. Flaggers are used only when all other methods are inadequate to warn and direct drivers. There are various procedures for flagging that can be found in the appropriate manuals. Flaggers must be properly trained. They need to know the correct way to stop, slow down, or keep traffic moving. Some agencies give a flagger a pocket instruction card. There are two types of work zones: shoulder operations and lane closure operations. Shoulder operations do not actually interfere with traffic, but they do require some devices. A single warning sign and vehicle warning lights are sufficient for maintenance activity or minor reconstruction. When an improved shoulder is closed on a freeway, the work zone should be closed off by a taper of channelizing devices. Work that closes off lanes of traffic falls into two categories. Closing off a two-lane, two-way road requires a flagger at each end of the work zone. Work on a four-lane, two-way road requires closing at least one lane. Channelizing devices will have to redirect the traffic from that lane to a new one. New safety products are coming along all the time. Here are some examples. This is an early prototype of a portable rumble strip. It will warn motorists they are approaching a work zone. Flaggers will be happy to use the flashing Stop Slow paddle. It is highly visible, and tests show it gets the driver's attention. The infrared intrusion alarm will warn workers of errant vehicles. A lightweight, easy-to-set-up detector is placed at the beginning of the work zone. If the beam is broken, a siren warns workers. A remotely driven vehicle protects work crews as well as the driver of the vehicle. The RDV, as it's called, is a dump truck modified to operate as a driverless shadow vehicle. In this program, we have covered the basic principles of work zone safety, traffic control zones, planning for traffic control, the function of traffic control devices, and typical applications. The basic principles emphasize safety, keeping traffic moving, clear and positive guidance, and inspection. The 5 parts of a traffic control zone are the advance warning area, the transition area, the buffer space, the work area, and the termination area. Planning for traffic control has one ultimate goal: maximize safety and convenience at a reasonable cost, and consider the hazards and problems involved. This means minimizing accidents while maximizing convenience. A traffic control plan is a blueprint for handling traffic through a work zone. It is often a legal requirement. In fact, it is required for all federal aid projects. It should include traffic control strategies, staffing requirements, use of specific devices, and design of geometric features such as tapers. Traffic control devices work together to provide a safe travel path through a work zone site. Devices include signs, signals, pavement markings, and delineators, which are covered in the videotape Worldwide Traffic Sign Systems. More specific to work zones are channelizing devices, lighting devices, shadow vehicles, and flagging procedures. There are 2 types of work zones: shoulder operations and lane closure operations. Usually, a single warning sign or vehicle warning lights are enough. A closed, improved shoulder requires a taper of channelizing devices. Work that closes off lanes of traffic falls into 2 categories: closing off 2-lane, 2-way roads, and work on a 4-lane, 2-way road closing at least 1 lane. For more information on these concepts, check the manual on uniform traffic control devices or other similar documents. For more information on other IRF videotapes, call the International Road Federation at the numbers on your screen.